Section P5, Preview 5, Factoring Polynomials. Before we factor polynomials, let's look at expanding, kind of like the other way around. So if you have 2x and multiplied by x plus 3y, you do distributive property. You distribute 2x times x is 2x squared. 2x times 3y, 6xy. If you have something like x plus 3 times, let's say, x minus 5. So how do you multiply this out? You take x multiplied by the whole factor plus 3 times the whole factor. That gives us x times x, x squared. X times 5, 5x. 3 times x, 3x. 3 times 5, 15. So that gives x squared minus 2x minus 15. That's called expanding. Now the question is how to factor. How to factor polynomials. Factor means write it as a product of factors, 2 or 3. So let's say we have 6, right? Like just the number 6. Number 6, it's 2 times 3. 2 times 3. So what I did, I took 6 and I wrote it as a product of factors. This is a factor and this is a factor. 2 factors. So if we need to apply it to polynomials, say example 1, 2x squared plus 6xy. I want to factor this out. When I want to factor this, I look at the numbers 2 and 6. What do they have in common? What's the greatest common factor for these two numbers? Well, the 2. For 2 and 6, the GCF is called. The greatest common factor of 2 and 6 is 2. For the x's, x squared and x, we take the smaller one. Y, there's no y, we don't take anything. So what is left? What times 2x? What times 2x gives me 2x squared is x. Plus, what times 2x gives me 6xy is 3y. 3y. Look at another example. For 9 and 15, what's the common factor? The largest is 3. And you can, there's many ways to find that out. You can list the factors of this. 1, 3, 9, those are the factors. 1, 3, 5, 15. So the greatest common factor, as you can see, is 3. 1 is a common factor, but the greatest is 3. Among x squared and x cubed, we take x squared. The b squared and b, we take the b. And what is left inside? Let's see, 3 here. B plus, I need a 5, because 5 times 3, 15. The x squared, I need an x, and the b is already there. 10x squared, as another example, 25xy plus 5x. Among all of them, what is a common factor among all of them? 10, 25, and 5. It's a 5. The x squared, x and x, we take the x. Y, there's no y's in the other ones, we don't take it. What is left? We need a 2x here, plus we need a 5y, plus 1, plus 1. That's how you do common factoring. Now, another kind of factoring called trinomials. How do you factor trinomials? Something like 5x squared plus 5x plus 6. Those are called trinomials because it has 3 terms, 1, 2, and 3. 3 terms. All the trinomials that we try to work with, we open 2 parentheses like so, to have it written as a product of factors. And how do you do this? We go first with the x squared. It's x times x squared. Both signs are positive. The 6 can be either 6 times 1 or 2 times 3. So let's start with 6 and 1. It's called trial and error. You try to make an error, you try it again until you finish it up. And now how do we check the answer? How do you check the answer? You multiply these together, 6x, multiply these together, x. Add them up, you get 7x. Does that match the middle one? No. So that doesn't work out. 6 and 1 doesn't work. We have to try another one. This didn't work. How about 2 and 3? So 2 by x, 2x. X by 3, 3x. If we add them up, you get 5x. That's the middle one. So that's the right way of factoring. So x squared plus 5x plus 6 equals x plus 2 times x plus 3. Another one. X squared plus 9x plus 14. And we're going to look at y squared plus 10y plus 24. Let's see. X, both are positive. 14 is 14 by 1 or 7 and 2. These are the only options. If you try 7 and 2, or if you put 2 and 7, it's the same. And test it out. This is 7x, this is 2x. If you add them up, you get 9x. That matches the middle one. So that's the right way of factoring. There's other ways people usually try to factor. It doesn't matter which method you use, it's all fine. The next one, y and y, both are positive. 24 has a lot of options. 24 by 1, 6 by 4, 12 by 2, 8 by 3. You have to try them. 24 and 1, I'm sure doesn't work out. We try the next one, 6 and 4. Try 6y and 4y. That gives me 10y. That's the middle one. So that works. 2m squared plus 5m plus 3. Let's try this one now. We open parentheses. 2m and m, because it's 2m squared. Both are positive. The 3, there's only 3 and 1. So 3 and 1. Let's test it. This is m, and this is 6m. If you add them up, you get 7m. Oh, that doesn't work. That doesn't match the middle one. Let's try it here on the side. One other thing we can do. Notice 3 is only 3 and 1. But since there is a 2 in the front here, when you put 1 and 3, it's different than when you do 3 and 1. It's different than doing 3 and 1. So let's test it now. 3m and 2m. Add them up, you get 5m. That matches the middle one. So we are good. That's the right factoring. Another one, 2x squared plus 9x plus 10. Always pause the video and try. We'll look at other examples where we throw different signs like negative signs. For this one, 2x and x, both are positive. The 10 is 10 by 1 or 2 and 5. So if you put 10 and 1 and try it, it's not going to work out. Let's try 2 and 5. This is 2x, 10x. That's 12x. That doesn't work out. Doesn't match the middle. Again, as I said, you can swap 2 and 5. Make 5, 2, 2, 5. It makes a difference. Put the 5 here and the 2 there. That's a 5x and 4x. That gives me 9x. So that's the right way of factoring. How about the next one? XX. So now both signs are negative. So to get negative 10, either 10 and 1 or 2 and 5. But one of them has to be positive and one to be negative. So the product is negative 10. It's not 10, negative 10. So if you try 10 and 1 and multiply, it's not going to work out. How about if we try 2 and 5? 2 and 5. Negative 2x and 5x. Add them up, you get positive 3x. Does that match the middle one? No, the middle one is negative 3x. So in this case, what we do, we just swap the numbers again. 2 and 5, make it 5 and 2. 5 and 2. So that would give us negative 5x and 2x. Then that will work out. So the right way of factoring x squared minus 3x minus 10 is x minus 5 and x plus 2. Another example, y squared plus 7y minus 18. And then we're going to look at y squared minus 9y plus 18. I'm just changing the signs, one positive, one negative. So this one, again, it depends which guessing you get. 18, it's 18 by 1, 6 by 3, or 9 by 2. So 18 by 1 is not going to work out. If you try 6 by 2, again, it's not going to work. You can try it. 1 has to be minus 1 plus. Try 2 and 9. Let's see what you get. Negative 2y and 9y. That's 7y. Yeah, that matches the middle one. Next one. Again, y. Notice there's a plus here, but the middle one is minus. So if you put both plus, you would never get minus. So this means both of them must be minus. So their product will be positive 18, and the sum will have a negative sign in it. So 18, again, 18 by 1, 9 by 2, or 6 by 3. I would say 6 by 3 or 3 by 6. And test it out. It should work. Another kind of factoring is called difference of squares, which if you have something square minus something square. The way this is factored, you cover the exponents. You got x minus y. Copy the same factor, just make it a plus. Instead of minus, make it plus. So how do we factor y squared minus 9? Or 4m squared minus 49? So if you like, first you try to rewrite it as something square minus something square. And then you finish the factoring. Y squared is y. The 9 is 3 if you square it. Cover exponents, you get y minus 3. Same factor, just a plus. Based on the formula above. For the next one, 4m squared minus 49. This is 2m and 7. So that would give you 2m minus 7 and 2m plus 7. 9m squared minus 25t squared. Again, you can write it as something square minus something square. What is that? 3m and 5t. That will give us 3m minus 5t, and the same thing, 3m plus 5t. The next kind of factoring is called common factoring, where they are given in the form, let's say, something like this. To factor something like this, we look at the plus sign. It's the one that separates the terms. What's common among these two terms? It's x plus 5. I see it in both. If you cover those two, x plus 5 in blue, what do you see? You see 2x plus 7. That's the common factoring. Another one is the grouping. The grouping is usually used if we have 4 terms, something like xy plus by plus ab plus ax, let's say. And I want to factor this. So what do? We group them. We group them two at a time. So let's say I want to group the first 2 together and the last 2 together. What's common among the first 2? I see y in both. If you cover the y, that will give you x plus b. What do you see here? I see a. That will leave b plus x. B plus x or x plus b are the same. So let's keep this the same. I'm going to swap these, make it x plus b. It's the same. So now it looks like the previous example. These two, what's common? X plus b. Cover those, x plus b. That will leave a plus y or y plus a. Another example. X cubed plus x squared minus 7x minus 7. What is common among the first 2 terms? x squared. That will leave x plus 1. And what is common here? There's a negative 7. But what goes inside? Not x minus 1, x plus 1. Imagine you're multiplying this inside. You should get the one right above it. So now what is common here among this and this is x plus 1. If you cover them, that will leave x squared minus 7. Two more formulas to know, which rarely used, as the a cubed minus b cubed. The formula said you cover the exponents, you get a minus b. Then you square a, switch this middle sign to plus, multiply them together, and always plus b squared. Same thing for a cubed plus b cubed. Cover the exponents, you get a plus b. Square a, switch the middle sign, multiply them, plus b squared. As a quick example on this, 8t squared plus 27w cubed plus w7, 27w cubed. So what do we do for this? I want to rewrite it as something cubed plus something else cubed. The 8 is 2 because 2 times 2 times 2 is 8, and t. 27 is 3, w. What does that give us? Cover the exponents, you get 2t plus 3w. Square the 2t, you get 4t squared. Switch the middle sign, multiply this and this, that's 6tw. And square 3w, that's 9w squared. 9w squared.